at the end of the event as well. I'll hand it over to Umesh.
Okay, so great. Welcome back, everybody. So our next presentation is going to be by Dan Stamper-Kurn, who is professor of physics here at Berkeley. He's also the director of the Challenge Institute for Quantum Computing and the director of the Center for Quantum Coherent Science. So Dan is a leader in quantum atomic physics, and he's pushing towards an effort to explore new hardware in AMO-based quantum computing. I guess this goes under the name of with this emphasis on future-proofing quantum technologies. So I'll turn it over to Dan.
Okay, good. You guys can see and hear? Yes, Andrea's sort of.
Yes, we can.
All right, great. Great. So first of all, let me offer my thanks to the Science Institute for being a really terrific and crucial partner for the Challenge Institute for Quantum Computation. It's been a terrific partnership that has really allowed us to have a lot of connection and a lot of positive influence on quantum computing. I want to thank also Umesh Vazirani, who's we're all hearing from time to time. Umesh is our link to the Simons Institute, who's the co-director who sort of oversees our connection with the Simons Institute. And as you know, he put a lot of effort into putting together this very meaningful industry day, and I'm very grateful for all that effort. And then let me thank all of you for coming and participating. It's really great to see so many familiar faces and other people that I've sort of been reading about in the quantum news over the years. So let me introduce the CIQC, the Challenge Institute for Quantum Computation. And here's our mission statement, if you will. We're formed in order to address the fundamental challenges to the development of the quantum computer. So I'll tell you a little bit about our center. Hopefully I won't take too much of your time. Okay, so this all began back in the book of Genesis, when the National Quantum Initiative dictated that the National Science Foundation should establish several quantum centers for quantum information science research and also for workforce development. And then that is then developed, and 5 of those centers now exist. So last year, 3 of these centers were founded. Ours, which I'll tell you about, the QSense Center, which is centered in Boulder, the HCAN Center, which is centered in the Midwest, in particular, University of Illinois in Urbana-Champaign. And then recently, in the last couple of weeks, perhaps the last 2, we'll see how many more there can be, Quantum Leap Challenge Institutes were founded. They don't really have snazzy names yet, but one of them is centered at the University of Maryland, focuses on quantum simulation. And the other one, centered at the University of Chicago, focuses on quantum sensing for biological applications, whereas the one in Colorado is more in the time and space division of sensing. So you see that among these Quantum Leap Challenge Institutes, ours is the one that is dedicated specifically to quantum computing, and so is maybe most relevant for the gathering that we have here today. So in founding the CIQC, we sat together. Umesh was critical for these discussions, as were several other colleagues, and we asked ourselves, what's the special role that an academic institute should now play in this very new era of quantum information science, where there are major industry efforts, which many of you represent. There's major national lab efforts, which we'll hear about in a couple of minutes, and other government efforts to try to build a quantum computer. With all these large entities working in this space, what's the right role for academic institutes such as ours to play? And the focus has been on this concept of future-proofing, which is really a question of time horizons. I think an academic institute ought to look, far into the future. You pick your favorite time horizon, whether it's 10 or 20 or whatever number of years, and we should be considering what will be the obstacles that stand in the face of the future developments that we hope to see, and then what obstacles will that new development create? What will quantum computers wreak in the world, and how can we overcome those challenges as well? So thinking about that kind of time horizon, we thought was very complementary to what is happening in industry. Industry will be, perhaps more focused on the nearer term, on specific technology choices and particular approaches, but can't also necessarily be as concerned with the far future. Also, that farther future is a place where academia and industry can come together and interact without, too much concern about competition and intellectual property and all, secrecy. If we can together look at the farther future, and we all agree that we should work together on addressing problems that arise there. So the research effort is focused on three specific challenges, which you'll recognize. One is the challenge of developing algorithms, both for the NISQ, but also the future era that will make the effort to build quantum computers worthwhile. The second is continuing this tradition of trying to establish quantum advantage over classical information devices in a wider range of problems of greater relevance, and also a wider range of platforms. And a third is tackling sort of at a fundamental level what all of us are facing, which is that our quantum computers, when they get bigger, they also get worse. So we chose in particular to focus on optics-based or atomic-based platforms for quantum computing, because we felt on one hand, they come in a variety of scales, so it's good to understand the problem of scaling in these systems. And secondly, it seemed like an area where there wasn't as intensive development at the national lab and industry level, so we could play a complementary role. In terms of what we actually do, maybe it's described perhaps by who we actually are. And I think if you just look at this cast of characters, you'll sort of recognize what kind of research activities we're working on. I mean, these are all people that are working already at the top of their disciplines. And what we're hoping to do with the CIQC is pull them together and get some sort of value added by working together in teams, and perhaps also including many of you as partners in addressing some of these fundamental questions. And the CIQC is a network of several institutions. So there's 8 universities in total that participate. It's largely centered within California, but we also have some members from outside of California that provide really essential expertise. And then our institute also has 2 very essential partnerships. One of them is the one with the Simons Institute, which brings us all together today. So you all are familiar with the important role of the Simons Institute as now the hub for theoretical quantum computer science. And then also IPAM, which is the Institute for Pure and Applied Mathematics at UCLA, which plays a similar role, but in the area of mathematical sciences. If you wanted to work with us on specific areas of research, here's one recent version of the working groups that are to varying degrees active and pursuing collaborative research within our institute. Some are kind of in the area of quantum algorithms, some are kind of in the area of quantum advantage tests, and some are kind of in the more hardware and scaling quantum systems area. But if you look at the specifics of these topics, you'll see that they cross over between the different pieces of this research program as research in quantum information science naturally does. We also are very active in educating students and postdocs, also faculty, and then with the idea of developing the workforce that is probably going to go out and work in many of your efforts and many of the other companies that will be established to compete with you. And we have a pretty broad range of education and workforce development programs. I'll highlight a few of them. One of them is the establishment of a master's program, which Michael warned us against in the previous session, but we do indeed have such a master's program coming together at UCLA. Another thing of interest is winter schools, which then turn into video boot camps that we hope can be used to educate all of us. I mean, all of us at this gathering have expertise in a part of quantum information science, and maybe there's other parts where we'd like to learn more. So even at the faculty or senior scientist level, these kinds of video boot camps can be useful. And then another one, which I'll talk about in a second, is this undergraduate research program, which pairs undergraduate researchers with questions posed by industry.
5 minutes remaining.
Thank you. In terms of interactions with industry, I mean, this is kind of what an academic center, I think, should be doing. One of them is, we have programs and ideas for preparing our students to enter and eventually lead the quantum industry. So our students and postdocs will be gaining access to all sorts of sort of professional training opportunities. And we hope also that partners in industry can help mold these and also participate in them as some sort of mentors. We also hope that the CIQC can establish sort of a zone where academia and industry can get together and interact and talk about what are those, those coming challenges that we can work on together. And then third, of course, we are building up the quantum industry workforce, and we have some specific plans. And I can't talk about the real specifics, but we should have a robust program for internships that would take place over the summer for undergraduate students. We have a lot of undergrads deeply interested in these, and also graduate students in both theory and experiment, and also our postdocs. So now, with all the industrialists sitting in the audience, here's what I want from you. One is, I would love for you to participate in this quantum research in industrial projects for scientists program. So here, this is led out of IPAM at UCLA. It selects top-notch undergraduates from around the country to work with industry and academic mentors on problems that are posed by industry. So we had a pilot project, or the first year project, where a question was posed by IBM. Dmitry Maslov acted as the industry mentor, and it was a tremendous success. 4 students worked with him and produced a very impressive report, which is actually going to appear in a publication hopefully soon. So I would love for you to contact us and participate in this program and suggest good questions to work on over the summer with undergraduates who'd be living in UCLA during that time. A second is, there's a huge appetite for summer internships to go work in industry. So contact us, let us know what would be opportunities. We'll do our job of matching those ideas to the people that we can provide from our center. A third is, we'd love for you to join us in sort of an industry consortium. We're forming 2 hubs that would either be focused in the Bay Area or in the Los Angeles area. And this would let you play, what we need is an active role in setting up the exchange between academia and industry, so we can be working on things of mutual interest. And then finally, please stay informed. There's a way of knowing about the Simons Colloquium that happens weekly, the CIQC Colloquium that happens weekly, and other events, and we would welcome all of your participation. So that's it. Thanks for your time.
Great. Thanks a lot, Dan. That was a great presentation. Next on the program, we have a presentation by Rick Mueller. He's the